someone who was a contemporary of Eratosthenes was Archimedes, who's like one of our favorite historical characters ever. He's so awesome in so many ways. Um, but yeah, so he was around the same time, around 250 BC. He was born in I want to say like 287 BC, I think. Um, so Archimedes did a whole bunch, and I could go on and on singing his praises. But for the purposes of this discussion, he was the first to kind of prove the approximation of pi in a rigorous mathematical manner. And I just admire this because I would not have come up with this in 100 years. So I'm just so impressed by what Archimedes came up with. So he's trying to figure out pi, and he knew that pi was the constant um, that determined the relationship between circle's diameter, right? Like the line that goes through the center from one side to another. Um, so there was a relationship between a circle's diameter and its circumference that never changed, and that's pi, right? He's like, well, how do I calculate that? Well, I'm going to start with something like an equilateral triangle or an equilateral quadrilateral, which is a square. And if I draw it such that the corners of one square are tangent to the circle and the sides of a bigger square are tangent to the circle, I can calculate based on the radius of the circle, um, the perimeter of this inner and outer square. And I know that the perimeter of the circle, the circumference, is somewhere in between. So I can bound um, the pi based on this. And it's not close. But then what I can do is use different polygons with more sides. That'll get me closer to the inner and outer bounds of pi, right? Like so a equilateral six-sided polygon, a hexagon on the inside and outside. Like that obviously looks like it's a little closer to the circumference of the circle. Um, so, you can calculate the perimeter of this square based on this is the radius and this is the diameter of the circle. You can now calculate, r is like I don't think he would have had the square root of 2, but he would have had something like that. So the inner perimeter is around 4r square root of times the square root of 2, and the outer perimeter is 4. So, pi is about 3.14. So between 2.83 and 4, right? That's not close, but pi is in there. And now as you increase the sides of the polygon, the inner and outer polygon, you can get a little closer. I just think that's absolutely brilliant. I think he got up to like something ridiculous, like a 60-sided polygon. It was really impressive. Um, so again, let's just kind of show you how he did what he did, what I think is amazing.